Assalamu alaikum. In this video I will be explaining the method to create this metric wrench on Autocad. These diagrams have been clipped from the book of Engineering Graphics with Autocad 2006 edition by James D. Bethune, and from the book this diagram was clipped, and this is exercise 2-13, and a file was compiled, and this diagram is on page number 11. So I will be explaining the method to create this diagram in Autocad. So as we observe that first of all we will be opening the respective template depending upon the units and environment, whether 2D or 3D. So because this is a two-dimensional diagram basically, and units are millimeter, so we can open here Autocad ISO template, because this template specifically contains toolbars and commands relevant to two-dimensional environment, and the units are by default set into millimeters. So I have opened this template, and the next step that we should do is we will once be clicking on zoom extent on view, or we can simply type letter Z on the command line, and then we can press letter E and then press enter to zoom extent, so that the whole model space screen is maximum extended to the this display for a better view. Though no geometry has yet been drawn, but we must first of all click on zoom extent. Now we will be starting to draw this diagram. We can start from this left jaw. So as we can observe that there is a hexagon, and its dimension is shown here 25, which is actually the distance across the flats. Flats are the opposite sides in an even-sided polygon. So as hexagon has 6 sides, so its the distance between its opposite sides will be equal to 25 units, as it has been mentioned here. And the type of the polygon that we will be using, that will be circumscribed about the circle type of polygon, because the specifying circle will be made inside this polygon, or this polygon will be circumscribed about that circle, and the sides of this hexagon will be externally tangent to that specifying circle on their midpoints. So that means the type of the polygon will be circumscribed about circle, and the radius for the describing or specifying circle will be half of the distance across the flats, which is 25. That means 25 divided by 2, which comes out to be 12.5. So in this way, another task or requirement will be to locate the center of this hexagon. So it is better that we first of all draw this circle of 40 diameter, which has actually no connection with this hexagon. Students often confuse and that they are mistaken that this hexagon is inside this circle, so this is a inscribed type of polygon. This is never the case, because this circle is actually independent and it has no connection with this hexagonal jaw or shape. This hexagon will be specified or described by an invisible circle which actually physically will not be shown or drawn. That will only be specifying the size of this polygon. So but to locate the center of this hexagon, because this hexagon is concentric with this circle, their center is same, so it is better that we first of all draw this circle of diameter 40 millimeter. So we can click on this circle command and click on any random point here, for example, and then we can click on, as it is shown here in the dynamic mode, specify the radius of the circle. As we can either type the radius to be half of the diameter, or if we want to directly input the diameter, we can click on down arrow from the keyboard, and here the diameter option will be listed, and now we can input the diameter and we can simply type 40 millimeter, and we can again zoom extend, and in this way we will be moving the wheel on the cursor so that to control its zoom, or we can zoom real time from here like this, and then we can pan it for a better placement at proper location. As this circle of diameter 40 diameter has been drawn, now we will be drawing the hexagon. So we will click on polygon command, and then we will be, first of all, it will be showing that specify the number of sides, and by default it is 4. As this is hexagonal jaw, we will be typing 6 sides. And now the center of the polygon, will be specified with this circle. So we can first of all check that center O snap must be on, and to show the center O snap, we will be hovering the cursor on the boundary of the circle. Student at this stage make a mistake that they directly bring the cursor near the center. Remember that the center of the circle, center O snap, will not usually be shown when we move the cursor near the center. Center O snap will be shown when we will be hovering the cursor on the boundary of the circle, because that is actually the property of the boundary of the circle, and this is the center of the boundary of the circle. So as soon as we click on the boundary of the circle, the center O snap is shown. Now we will be specifying the type of the polygon, which is circumscribed, and the radius of the circumscribed circle will be half of the flats, which is equal to 12.5. so we can type here to be 12.5 here like this, and hexagon has been drawn. Now we will be specifying this radius R3 circle, and remember we will be creating this circle, and the type of this circle is actually tangent radius, because this circle is internally tangent to this circle of 40 diameter, and externally tangent to this side of the hexagon, this upper side of the hexagon. So this R3 radius, which is actually tangent radius circle, that is tangent externally on this side, this upper side, and internally tangent to this external 40 diameter circle. So we will be clicking on or using this tan radius command, and then we will be bringing the cursor at the approximately where we want the circle to be tangent at approximate correct location. So this is the correct location where the circle is physically or in the diagram located where we want, and here in this way. And now we will be typing this radius, that is 3. So in this way the tangent circle will be drawn, and we can either here draw independently the tangent radius circle, or we can just mirror this circle like this. We will be clicking on this, then we can either right click or we can enter. So clicking on right click after selecting the object is equivalent to pressing enter from the keyboard. So I have right clicked here, and then we will be from here activating the endpoint ocean app, and we will be clicking on this point because this horizontal diagonal is actually the mirror line for this circle, and we will be clicking on here, and then it will be asking that you want to erase the source object. So we will be clicking on no, and in this way the tangent radius circle will be drawn. Or alternatively we can independently draw this tangent radius circle like the way we had drawn this circle priorly by activating tangent ocean app. So in this way this jaw has been roughly completed, and we will be trimming in the last stage once the diagram has been completed. Our next task is to locate the location of this right jaw. So there are two techniques. One technique is that we can either draw a center line or simple line using polar coordinate relative coordinates, and another technique is that we can draw this hexagon and this circle and this hexagon concentric with this circle and this hexagon, and then we will be moving them at the proper location. So both are these ways are equivalent and easier. So for example, because we are to draw this center line in every case, so it is better that we can draw as the center line. So we will be clicking here. So first point has been defined, and now this endpoint is actually in fourth quadrant with respect to this point. So this center point, this is actually in fourth quadrant with respect to this point, and its coordinate will be in the fourth quadrant. X will be plus 30 and the y coordinate will be minus 35. So we will be typing the relative entry. So in this way we will be putting the @ sign, and here we will be typing 130 and then putting comma, we will be putting comma sign and then minus 35, and in this way we will be observing that the line is located here like this. Now we will be drawing a circle. For example, center diameter option can be used directly. So circle diameter which is mentioned here from the diagram, it is actually 50 diameter. So 50 diameter circle will be drawn here, and after that we observe this hexagon. And remember that here the distance across the flats of this hexagon is shown 30 units, 30 millimeter, which is a mistake or wrong. Remember, this must be 35. This distance across the flats is 25 and this is 35. This is not 30, because if we take the dimension of the distance across the flats to be 30 units, 30 millimeter, then this R3 circle is not possible. So either we must change the radius of this tangent radius circle, or we can type this dimension to be 35. So as the hexagonal jaws, this tangent radius dimension is same, this is correct, but this dimension is actually wrong. So this must be 35. So kindly make this correction and note it. So the type of the hexagon will be circumscribed about the circle, as it has been already explained. So we will be drawing this hexagon, clicking on polygon, and number of sides again 6, and center of the polygon is we can click on this endpoint, or we can bring the cursor on the boundary of the circle, and the center O snap can be shown here. As we are bringing the cursor on the boundary of the circle, center O snap is shown. So here we can click on either center O snap, and then we will be typing clicking on the circle about circle type, and then the radius of the circumscribed about circle type of polygon will be equal to half of the 35, which is equal to 17.5 units. So we will be typing 17.5 units, and in this way this circle has been drawn. After that we will be starting tangent radius command, and then we will be activating the tangent O snap. If not it is active, then we will be activating it from here. From this tangent O snap we will be checking it, it is already active, and then we will be clicking at the approximate location here and here, and then we will be typing its radius to be 3 units, and in this way this TTR circle, tangent radius circle, has been drawn. We can independently at this stage can draw another tangent radius circle and the same dimension, and in this way these circles have been drawn. After that we will be using this offset command, and we will be clicking or offsetting this central line as we can observe here that this central line will be offset 10 units in this direction and 10 units in this direction and either directions. So we can specify the offset distance to be 10 units, and then we will be clicking on this line, and we will be clicking in this direction once, and we will be clicking on this center line again, and we will now be clicking on this side if the offset is same, and then we will pressing enter, and the offset command is finished. Now we will be trimming very carefully the unnecessary portions. For this we can either zoom these jaws, and we can here like this, and we can trim like this, and we must also zoom window, because here the traces of edges were here, so we must zoom window, or we can just rotate the wheel of the mouse. So zooming in, and now we will be trimming these portions as well on this right jaw, and similarly we can. So in this way, roughly this diagram has been completed. Again we can zoom like this, and we will also be trimming like this. So this rough diagram has been completed without dimensions. Now we can change the type of this to be center line. So what we can do, that here the line type, this is line weight and this is the line type, and we can click on the other, and then we will be loading, and then we will be selecting available highlighting any one pattern, and then we can just press letter C from keyboard, and this center type pattern is highlighted. We can use the default pattern, click on OK, and just simply we can click on OK, and here in the list we can show center is listed here. Now what we can do, how to apply it, we will first of all be selecting this line, and then from this list, pull down list, we will be clicking on the center, and in this way the line will be changed into center. Our next task is that the scale is much larger. We want to reduce the scale so that the center line looks somewhat similar to this. So what we can do, that we can select this line, and then we can type on the command line properties, and then we will be pressing enter, and here the line type scale, for example we can reduce it to 1/4, means 0.25 for example. This is just our observation, and whatever the scale we like, there is no specific thing. So as we can observe in the back end, that this line has been changed into proper scale. Now the important task is to dimensioning. Dimensioning is very important. So we will be dimensioning this diagram. So first of all, we will be adding the center lines to these circles. So what we can do, first of all we will click on dimension style, and then click on modify, and then go to symbols and arrows tab, and click on here line, and if the center line type pattern is not shown here, then we will go to fit area, and we will be in fine tuning, we will be confirming that this checkbox must not be checked, so we will be unchecking it. So here the center line type pattern for the circle will be shown here, because the circle is actually symmetric about both the x-axis and y-axis, and all its coordinates are actually identical and symmetric. So and some other settings we can do for the dimensions, that is that we will always be text alignment must be horizontal, and here in the text placement vertical and horizontal both must be centered. So these are the necessary settings, and now we will be clicking on the center mark command, or we can simply type dim center on the command line, and then we will be clicking on the boundary of this circle, and then we will again pressing, and then we will click on the boundary of this circle, and this in this way center lines will be added. After that we will be adding this 130 and this 35 lines, and remember the origins will be the end of these circle center lines. So what we will be doing, that we will be clicking on this linear dimension, and then we will be clicking at this point and this point and the ends of the center lines, and then we will be typing here like this. And as we can observe, if we want to change the offset from the origin or other parameters, that we can change simply here. If it is not according to our desires, then we can click on line tab area and offset from the origin. For example, it is 0.625. for example, we can type it to be point for example we can set it exactly 1, and we can also change the text size, for example 2.5, for example 3, and symbol arrows in the arrow size must also be, for example 3 units, and offset from dimension line in the text can also be changed, for example to 1 unit, so that a better view is shown here. And we can click on set current and close, and as we can observe, a better view is shown. And after that we will be again using the linear dimension command, and we will be clicking here and at this center line location, and we will be placing this dimension 35. So 130 and 35 dimensions have been very carefully placed at their precise locations. And after that we will be showing this R3 radius. So we will be clicking on this radius dimension, and then we will be clicking here like this. And as we can observe that this center mark is automatically added. So for example, we can first of all we can hide it like this. We can clicking on dimension style, go to modify and symbol arrow step, and for example we can click here mark none, for example, and then we can set current and close, and we can observe that center mark is vanished. This is one method. And another method is that, for example, if we undo it, then as this plus sign is actually integral or one object with this R3, this leader, so we can use, for example, the explode command, and then we can click here as it is highlighted, and then press enter, and now we can simply select this plus sign and delete. So in this way this can also be deleted. So R3 dimension has been shown here. After that we will be showing this 540 dimension, this 540. So let us show it at the proper location. Here this is 540, it is shown, and it is no further correction. So this dimension has also been satisfied, and our next task is to show this 25 dimension. So this is a simple linear type of dimension. We will be clicking here and here at these points, and we can place it at the proper location where it is shown here. This is this is sufficient gap here. we can for example redimension it here like this. So 25 dimension has also been placed, and after that we will be dimensioning this right jaw in a similar manner. We can type this, for example, diameter dimension, and here 550 diameter is shown here. So in a similar manner we can show here like this. For example, this is 50 diameter has been shown. Then we can show radius dimension of R3, so like this, radius R3 has been shown here. And in a similar manner we can explode and we type explode command here, and then click here, and then we can simply click them and delete. So R3 has also been shown. Now we will be showing the distance across the flats as to be here shown. It is actually 35. So this dimension has also been shown. So necessary dimension at the right jaw has been completed. After that, this we will be showing this 10 dimension. So to show this 10 dimension, because it is inclined line length, so first of all, if we simply type the align dimension, for example, for this we must activate nearest ocean app for the proper location here like this. And if we click here, as we can observe that 10 dimension has been shown. But our requirement is to show this 10 dimension like it is shown here. So it's one method is that we can, for example, bring this 10 at this location. For example, it is like shown here 10. And another is type that we want that these arrows should be shifted outwards, and this dimension line as well. So what we can do, that we can go to dimension style and modify and go to the fit area, and here we read if there isn't enough room to place both the text and the arrows inside the extension line. The first thing to move outside the extension line is we can check it here, both text and arrows, and then we click on OK, set current and close. And as we observe that this 10 has been arrows have been shifted outwards and extension line is also vanished. So in this way dimension has been completed. And we can also write it here, this metric range and exercise 2-13 millimeter in a quite similar manner as it is shown here. So we first type the metric range, so we can simply use single line text, and we can, for example, at the proper location as shown here, we can type here, for example, this is, and we will specifying the letter height, any suitable value here, and we will be setting the orientation to be 0 degree. And we can now type here, we can caps lock on and metric wrench. In this way metric wrench has been created, and above we can write exercise size 2-13 millimeters. So here you can also write your registration number besides this. So in this way this has been completed, and we can also change its location like this. And remember, if we want to change the size, so we can type the scale command on the command line, and then we will be selecting this object, and then we will be specifying any base point, and then we will be changing like this, for example. So in this way exercise 2-13, and this has also been mentioned. Here he has written only x 2-13 millimeter, so we can simply double click here, and then we will be removing this like this. So it is now exactly like that, x 2-13 millimeters. So in this way the diagram dimension have been completed, and now we can save it. So for example, I can save it as like name metric wrench, Now we must learn how to read the drawing and specify the clear areas. As we can observe that this is one area, this is the second area, and this is the third area. And as we observe that this area here, this line is shown here, this is the end of the left jaw. So that means the thickness of this jaw and this holding portion, whose width is 20 millimeter, the width is different, because if this face and this face are at different elevations, because if they were at the same elevation they would be treated at the single face. And similarly this right jaw also, this the thickness of this right jaw in the perpendicular direction is different from this area. So by visualizing this we can visualize this model, how it will look in the 3 dimension. So to create the 3D model, just to visualize, what we can do, we can first of all save this model in 2-dimensional as I have saved, and now we will again be saving its 3D copy. For example, we can type its name metric wrench 3D, for example, like this. And now we will be applying the region command. Region command, it is a 2-dimensional command, and the purpose of region command is to convert the individual objects into single objects, but it actually creates a closed loop. It actually creates a closed loop, and the loop, complete loop will be a single area. So the region is actually the first and foremost requirement prior to creation of the solid model. So if we want to extrude any area, it must be priorly applied the region command if it is not a closed loop and single object. So the necessary condition to apply the extrude command is that it must be the single object and closed loop, and the region command perform this operation, that it converts all the objects into single object, and also it creates a single loop. So as we can observe here, this is one object, this is second object, this is third object, and this is fourth object. So this is a closed loop, but it is not a single object. So loop condition has been completed, but it is not the single object. So we will be typing the region command, and then it will say select object. We will be clicking them 10 by 10, or we can simply simply window selection. Then we will be clicking on here, and if we activate the command line, for example control +9, command line is shown here, so that here the areas will be listed. As we can observe, we are bringing the cursor, hovering the cursor, now it is turned into a single area in this way. So in a similar manner, we will also be converting this area also into single area. So we can type on the command line, and we can observe that we will be selecting, and this also one region is created, here it is shown, and after that we will be converting this into a single area. But here, as this circle has been drawn and loop has been completed, so what we can do, we can for example either use the arc command. For example, simply 3-point arc can be used here like this. So this is the and here, or we can use this start, center, and end. For example, we can also use this option. So for example, we can start point of arc is, for example, this point, and this is the center point of this arc, and this is the end point of this arc. But we must know that, for example, we will be pressing control button to switch the orientation here like this. Now we will be clicking at this point, so that here, as we can observe, the arc has been drawn. So in a similar manner, we will be drawing the arc here. So start point of the arc is, for example, this point, and the center is actually the center of this circle, and the end point is here, and here is by default the arc is drawn in this orientation, so no need to press control. So in this way, now we will be converting this holding portion into single area. So we will be clicking on this arc, this object, this object as well, and or we can first type the region command, and then we will be clicking at this set of lines turn by turn, and then press enter, and as we can observe here, it is written one region created. So there are 3 clear regions have been created, areas have been created. So these are this area, one area, this is the second area, and this is the third area. And now we will simply be selecting click on the draw menu, click on modeling, and click on extrude command like this. And then we, for example, we assume that both the jaws have the same thickness, so we can click them in a single step. If the thickness is same, then we will be pressing enter or right click. So right clicking is equivalent to pressing enter from keyboard. We can enter, and then for example, we can visualize in 3D views, for example SW isometric like this, or we can show it in SC isometric like this. So we can again click on draw menu, modeling, and extrude, and click on these areas, both these areas, and we give a very minute dimension. For example, we can give just 1 millimeter dimension, for example. That is sufficient because it is a planar model. Or if we want to change our this dimension, so we can click on again on the extrude command. We can again click these areas like this, and for example we can type for example 5 millimeter like this. So five dimension has been specified. If we want to symmetrically extrude, so we can click on draw modeling and click on extrude here like this. Click here and click on this jaw, and then right click to press enter. And for example, we can type, for example, as we can observe that the positive z direction is upward. So if we type the negative value, that will be moved, the depth will be added in the downward direction. So for example, we can type minus 2.5, that half the thickness is added in the downward direction, and the half will be added upward. So to add the thickness in the upward direction, what we can do, that we can type another command, go on to modify, and then go to solid editing, and then we can click on here on extract edges. Here we will be showing this. In the 3D operations, in the 3D operation here, extract edges. So we will be extracting the edges of this solid model So here like this. So here as we can observe that these edges have been extruded, have been clipped. So we can click on again the region command type, and then we can select them turn by turn to create areas. So in this way we can observe that one region has been created, so another sketch has been created. So in a similar manner we can extract edges from the other jaw, left jaw. So click on extract edges and then click on this model, just press enter, and now what we can do that we can click on the region command here. This is I think here this is the region command. So here like this, and then press enter. So one region is also created here. So in a similar manner now we will be selecting both these extracted edges, and then we will be clicking on again on the draw menu modeling, on draw and modeling, and into extrude option, and then we will be typing positive 2.5 so that it is extruded in the upward direction. We can again observe that we will be selecting these edges, and then we will be clicking on extrude command, and in this orientation we will be typing, for example, 2.5. So in this way symmetric extrusion can be done. After that we will be clicking on this area, and in a similar manner we can extrude it first in the downward direction. In this direction, for example, we can extrude it a bit different, because the extrusion depth in the previous case on either direction was 2.5. so we can, for example, type it 1.5 in this direction, for example, minus 1.5 in the downward direction. So we can for example we can again extrude, as we can observe that this has been extruded. So we will first of all be again extracting the edges. Click on modify, go to 3D operations and click on these extract edges and click the edges from this face. So in this way now edges have been extruded, edges have been extracted. Now click on region command or type it and carefully select these upper edges here like this and click on enter. As we can observe, one region has been created. And now click on draw and go to extrude and again select this face and enter. And now in the up direction type 1.5 like this. So in this way this metric wrench has been completed. Now we visualize it in the 3D mode and conceptual mode, and as we can observe that along with the dimension, and if we look again in the top view orientation, as we can observe the solid model has been generated and its dimensions are also shown. As in the 3D model, dimension is quite meaningless, so we can remove it just by selecting turn by turn, or we can also make window selection. So this dimension, these all dimensions can be moved or removed from here, and like this, as we can remove all these dimensions and all these values. Here like this. So now we can orbit it like this, and we can show here as we can observe that there has been made a, I think, a slight mistake, because this downward extrusion, I think that was wrong, because this face is actually meshing this face. So we can either subtract or we can leave it here. So for our purpose is that this portion has different thickness with this, or that is why this edge actually was shown. So if this is a face at different, this face and this face, and all three faces are at different elevations. If they were at the same elevation, this line would never be shown. This edge line and this edge line would never be shown. If this part had the uniform thickness, then these lines, edges lines of these jaws would not be shown. So we must visualize and realize this fact. So in this way this model has been completed. If you have any question, you can personally meet and ask. Thank you and Assalamu alaikum.